All right, you want to solve the systems of equations. The first equation is 0.1x plus 0.9y equals negative 2. And we have 0.5x minus 0.2y equals 4.1. Right, so obviously the first thing we notice is we have decimals here. Okay, so we can deal with the decimals, however, probably best just to get rid of them. All right, now remember, a decimal place is just off by a factor of 10. Okay, so for example, if we multiply this by 10, that essentially moves the decimal place over one spot. And you notice, well, wait a minute, I can do that to all of these terms, right? Now, the main thing to remember is if we multiply this first equation by 10, we have to remember to multiply everything by 10. That means this moves over once, so we get 1x. This also moves over once, so we get 9y. But what is negative 2 times 10? Right? Essentially, the decimal place moves over once to the right, so we get negative 20. Okay? So similarly, we want to multiply the bottom equation by 10. And by doing so, we should get rid of these decimals, right? So we get 5x minus 2y equals 41. So let's rewrite these, right? X plus 9y equals negative 20. And 5x minus 2y equals 41. All right, so we've done the first step here, which is getting rid of the decimals. Now we actually want to do the solving part, right? So if we solve, right, we see that this term has a coefficient of 1, right? So that's good. So we're going to isolate this guy for x. We're going to get this x by itself and substitute that into the other x, right, in the other equation. Okay, so let's go ahead and do that work. X plus 9y equals negative 20. I can subtract the 9y to both sides. And then what do we end up with here? All right, 9y's cancels out, which is sort of the whole goal here. So x equals negative 9y minus 20, I should say, right? Minus 20. Don't want to make a silly mistake like that, right? We see the negative sign here. All right, so what do we do next? We want to substitute or replace this into the other equation for x. So 5 times x, but instead of putting x, we're going to put negative 9y minus 20. And you notice at this point, we should be able to solve this for y, right? This just becomes a linear equation that only has y's in them. Right? So we'll distribute the 5, negative 45y minus 100 minus 2y equals 41. Right, negative 45 minus 2 is negative 47y. And we can add the 100 to both sides to get 141. And in this case, when we divide both sides by negative 47, we get our final answer here, right? Y equals negative 3. So what's the last step here? Are we done with the problem? Remember, we are not. These are linear equations. Okay, we have to give the answer in terms of x and y, right? There must be some corresponding x value when y is equal to negative 3. How are we going to find it? Right, best thing to do is just plug it back in here, right? Notice x is negative 9 times y minus 20, okay? So, x equals negative 9 times negative 3 minus 20. This is positive 27. 27 minus 20 equals 7. Right, so how do we express the final answer? Right, you should always express the answer as an ordered pair, right? In this case, the solution should be the ordered pair 7, negative 3. Right, so if you actually drew or sketched a graph of each of these two lines, right? If you sketched a graph of each of these two lines, they would cross or they would intersect at this point.